sorry for the delay. So we got everything moved back a day. We have our second day of review today. I did want to tell you, I looked at a previous test for this thing that's coming up, and I had 15 questions on it, just to give you an idea of length. You know, as opposed to the review that I think has, what, 60? So obviously that's too long, but it provides good kinds of practice on a variety of problems. So anyway, that may not help you a lot, but 15 of that same style questions gives you, you know, time to, and then I'll have an announcement right on the test that says if you want full credit, make sure you show your work. So please don't you know, actually better off if you don't put stuff on scratch paper, get it all down on the paper so that, who knows, might even be a sketch that you made that might be worth something. And why not grab all the points you can grab? So anyway, where do you want to go? We've got this review. Last time I think most of the time we spent questions on 1.6, but I know I had a couple 1.4 questions. I'm going to just pull this out so I can have a little bit of a rough idea where. I guess I don't need that. I'll get that out of there. It shrinks everything a little bit, but it shows me the problems I have up there. What would you like to do? Get ready. Yes. Number 8 on page 45. So 1.4, number 8. Okay, what do we got going on here? Number 8. Decide whether the equation defines y as a function of x. Okay, we have x squared y minus x squared plus 4y equals 0. Well, we try to get our y's together, and what happens? We could add the x squared term to both sides. And then we could factor a y out of the left. And then we could divide both sides by that quantity. Yeah, it appears, I mean, when you can solve it for y, and you don't have a plus minus or something like that on the right, and we didn't have to do any square roots, so I shouldn't have had to introduce any. This looks like the answer should be yes. So, goal on a problem like that is try to solve it for y and see if you can just get it down to something only in x like I did. Should be okay. So I should put down, therefore, yes, y is a function of x. That little triple dot, I don't know if I told you guys, that's a shortcut for therefore. You'll see that in science and math classes. Yes, Christina. 78, did you say 94? Okay. 78, number 94. So this is the review. Okay. Let's trying to get a blank page here. Okay. I said that it's the opposite way, isn't it? Finally, okay. And the problem is find the limit. And it's a what? Right-hand limit? As x approaches 1 from the right of 1 minus cube root of x all over x minus 1. They want you to use a table. Okay. So in other words, yeah, and that makes sense because algebraically, I was just looking at this, and even though it's the difference of two cubed roots, it's not the difference of two cubes. There probably is a key. But anyway, I'll follow the directions. Use a table. Okay, well, I mean, to make things reasonably short here, I'm going to do it in the spreadsheet. Simply because I want to keep things moving as quickly as I can here. Let me get this shrunk a little bit. Okay, so I can see the formula. All right, now what we want to do is put the formula in here, which is, we're going to take what's in cell A1, which I haven't defined yet, and we are going to, let's try that again. Numerator, 1 minus what's in cell A1 to the 1/3 power divided by parentheses what's in cell A1 minus 1. Okay, now I'll just put some numbers in here. We're doing it by 1, so let's do what? Let's go, we're doing it from the right. So what I'm going to do is start at 5, and then I'm going to go down by, I don't know, 0.1. So let's say A1 minus 0.1. Okay, now copy this down. That didn't do it. Okay, now I went past 1. That's good. Now all I got to do is copy this formula down. So as we come down to 1 from the right, what's happening? It appears to be getting close to negative 0.3 approximately, or negative 0.32-ish. I could do it more precisely. It's interesting how it jumps at 1, but that's not what we want. We want to know what it's approaching. So negative 0.32. Now, I could get more detail by going by more than, instead of just tenths, I could have gone by hundredths or something. It's not a really very good question for my test, because I'm not going to give you a table question. So I maybe should have said that right away. Well, I think it's, I think it's a good question. I'm not being critical of the book. It's just not a good style for what, for me, for what the major things were we taught you in this chapter. So, Yeah. Why didn't I get to that right away? I don't know, but you know, it's really close to negative 1/3 too. I said negative 0.32. It might be that it's approaching negative 1/3. I could have gotten a lot better if I'd have done smaller increments. We could have gotten closer. Question?
29 on
77, 29? Yep.
Page 77.
Yep. Yeah, it says find the x and y intercepts of the graph of the equation algebraically, then use a graphing utility to verify that what you got is correct. Okay. So, number 29 on the review. So our equation reads y equals x minus 1 to the third power plus 2 times, do I have the right problem? Katie, x minus 1, good, squared. Okay, so it says find the intercepts. How do you find the intercepts? Well, the easy one to get is the y-intercept, because all you got to do is set x equal to 0, and that'll be real. So what happens when we do that? When we get negative 1, we would get negative 1 cubed, which is negative 1, and over here we would get negative 1 squared, which is 1, and 1 times 2 is 2, and we would get 1. Okay? But finding, it's not going to be as easy finding, so let's just say this is what? The y-intercept. So in other words, we now know that this point is on our graph, y-intercept. But what about the other one, x-intercept? All right, now we got to set y equal to 0 and see if we can solve for x. Yeah. I don't see any way out of this except to probably expand these and try to get them together and see what we can do to factor, because, okay, so let's see. Well, first of all, squared, this thing is x squared minus 2x plus 1. And I got to multiply that by x minus 1 again, plus 2 times the quantity, x squared minus 2x plus 1. Okay. Well, you know, one thing I could have done that would have been really easy, I could have factored an x minus 1 squared out of here right away, and then I had it factored, and then I could have set that equal to 0, and we can see that 1 is going to be, you know, you can see that x minus 1 equals 0, x equals 1. That would have saved us, and it still could save us, so I'm going to just say that. Okay, so I know that 1 comma 0 works. Are there others? There may be. Let's do the graphing and let's see what happens. Okay, let's see if we can get this in. There it is. Function insert. X minus 1 cubed plus 2 times x minus 1 squared. Yep, sure enough. Well, I did miss one. I did miss one intercept. I got the 0, comma 1. We did that right away. And I got the 1, comma 0. You can see it. The only one I didn't get is the negative 1, comma 0. And by further factoring this, I got to multiply this together, multiply this out, add them together, and try to work on factoring that. I probably could have found that negative 1 would have worked too. So anyway, that would be how to proceed on that one. It should right over here that this is the x. Yes. On the review? 35 on the review. Okay. Find the points of intersection of the graphs algebraically, then use the graphing utility. Okay. So, x squared plus y squared equals 5. Well, that's a circle whose center is at the origin and whose radius is the square root of 5. And x minus y equals 1. And that's a straight line. Okay, so where does the straight line cross the circle? Well, I think usually the easiest way to solve where do they cross is substitution. And over here we could just what? Add y, say x equals y plus 1. And then we could come back here and in place of x, plug this in and see what happens. So y plus 1 squared plus y squared equals 5. And this would be what? Y squared plus 2y plus 1 plus y squared equals 5. And that would be 2y squared plus 2y minus 4 equals 0. And I could factor a 2 out of there. And this is just what? Plus 2 minus 1? Is that right? And so we at least got the y coordinates. Now you'd have to go back and find x, and then of course you pull out and graph the circle and the line and show that they really do cross. Is that enough for you? Okay. You know, just one more time, my slightly different style of me from the book. I probably wouldn't have all those pull out your graphing calculator and check them. On the other hand, if you want to pull out your graphing calculator and check them, you could. But I probably wouldn't have that be part of the question. Yes? Oh, say that one more time.
How do you know the x equals 5 plus 1? Why don't you just say x equals 5 plus 1?
Well, I just took this equation and solved it for x.
Oh.
And that's where I got this y plus 1. So in other words, I used one of the equations they gave us. And I wanted to get it down to just like one letter. By the way, I could have solved for y too. And then we could have substituted it in place of y. And then we'd have gotten the x coordinates, which would have been okay too. Yeah. So if you ever want to know where, what's the fancy name for finding out where two graphs cross? It's called solving two equations simultaneously. That's probably what they called it in your previous algebra class. And one technique is substitution, which is what I use. You can also use the addition method, try to get or subtraction, subtract one equation from another, try to get a variable to drop. But this is usually substitution is the best. Another one you'd like to look at. Already I'm thankful for the questions you asked. Just while you're thinking, I'm going to just throw a little bit more advice in here. Final preparations for the test. Marathon sessions don't work very well. I've tried it. I don't know if I've ever had it really work well. You know, there are times when I came in just so full of information, and then I was really dull because I was up so late. And I think I spelled my name wrong and dumb stuff, you know, and then you do really stupid things. And of course, we all know it's possible. Everybody hates it when you get your math test back and you've done dumb things, you know. you did the really hard part right. Boy, are you happy. And then at the bottom you did 2 plus 3 equals 23 or something like that. Or 2 plus 3 equals 6. All right. So anyway, I guess what you probably, it doesn't hurt to study for a fairly long time. Just don't do it at the last minute, and get yourself a good night's sleep and a good, good breakfast and simple things like that. So you come in with a clear head, you probably do better. Try to be relaxed. Remember, I have no pressure on you time-wise, so you don't have to come in here and go, and do that trick. You don't have to do that thing. So just try to be as relaxed as possible. And I think you got the best chance of getting your max when you do some of those things. Yes?
32 in the review.
Sure. 32 in the review. Complete the square to write the equation of a circle in standard form. Then determine the radius and the center of the circle. Okay, this is number 32. Review. Okay, the equation that we're given is x squared plus y squared minus 6x plus 8y equals 0. First of all, you're heading for the standard form. It is important that, see, here's one of those things you really have to know. The standard general form of an equation with center at hk and radius r. That's really worth having in your head. Okay, so we're kind of headed for that. So the idea here is we're going to have to complete the square on x and complete the square probably on y too. So let's gather the x terms and the y terms together, and let's leave some space so that we can complete the square. And let's see, we can move that over a little bit. So now, good news. Both the x squared and the y squared have nothing but a 1 in front of them. That's the first thing you got to check. They do. So I don't have to divide anything through or factor. So now I can just start looking at the b term, the x coefficient, which is, in this case, is 6. Divide that in half, 3, and square it, 9. That'll make that a perfect square. Of course, I got to add it to both sides. Over here, the b term is 8. Half of that's 4. 4 squared is 16. So now this, I don't know, hopefully you can see. We really have this thing nailed now. Hopefully you can see where I got these from. Remember, this number is always two things. It's the square root of that guy, and it's half of that guy. If I did it right, 3 squared is 9, and 3 doubled is 6. And over here, 4 squared is 16, 4 doubled is 8. The signs are mimicked. Here was a minus, that stays. Here was a plus, that stays. So, what's our center? It is 3 comma negative 4. And what's our radius? The square root of 25, or 5. And that's, and then you're supposed to sketch it. I'll bypass the sketch. I think you should know the difference between them. A removable discontinuity is basically one of those where it's got a vacant dot, and but the graph connects. So in other words, The graph, the two pieces of the graphs have the same left and right hand limit, but there's a hole right where they meet. That's removable. And all you'd have to do is define one point, and that thing would be just beautiful. That's removable. But when you have something like this, there's no way I could stick a point in to make those two ever connect. Now, that would be non-removable discontinuity. So an asymptote is even this, where you have, there's no way one point's going to solve that either. That's non-removable. So just that you know the difference between those two, I think. I know some of you have never had one of my tests either, and you're probably wondering about style. The style is basically going to be a lot like, I mean, you're going to see questions like the review questions here. I'm not going to have, I just have never been real creative that way. I've had professors that, I remember getting in and looking at the test and going, holy cow, is this the test for this class? And here, a really unbelievably smart professor had this really creative test. And he had like 3 puzzles. And if I solved the 3 puzzles right, they led to a clue, which led to the final question. Oh my gosh, how did this guy figure this out? And of course, I didn't even know how to solve 2 of the 3 puzzles, so there was no way I was going to get to the clue. But I'm just not that creative, okay? My problems are going to look pretty much like these. You're going to see some of the same directions, except that, again, my emphasis will be a little bit away from checking it on your, I mean, I won't be forcing you to do things on your calculator, but you'll be welcome to use them. But what it is I really want to see is not your calculator results. I want to see your algebra, you know, any algebra work you do. You know, trying to think of an example. What if I ask you, here's a simple one. One thing we talked about in chapter 1 is finding the distance between 2 points, right? We learned the distance formula. I may give you a question and say, what is the exact distance between these 2 points? And I'll give you 2 points. And by exact distance, I don't mean 6.89994432. You probably would have to write an infinite number of digits to get that exact. And I don't know if I can give you that much time to take the test. What I mean by exact is square root of 50 or square root of 52. Of course, if you can simplify it, I'd like you to simplify it, but that is right on the schnozola. That's perfect. Decimals just don't quite cut it, okay? So please, there's an example of somebody might say, wow, I've always done that kind of a problem on my calculator my whole life. Are you mean you're changing me now? Yeah. Because from here on, it's that square root of 52 that you need, not that decimal approximation. So anyway, so, you know, you want to get all done and go, wow, I wonder if my answer is approximately right. Well, you can go ahead and use your calculator and see how close it is. That's no problem. So again, it's more of a confirmation tool. I know that there are some people teaching algebra that are really heavy into calculators. Honestly, I believe that's a disservice. I mean, I think they're great for exploring. And you probably noticed a lot of times after we get done with a problem, I like to graph it and say, let's see if we got it right. I think that's a great use. But if you rely on them to try to get your algebra done, now we're in deep trouble. So anyway, but just so you know, most of the math classes here on campus, they won't even let you use one. So I'm pretty open that way. Yeah. Sure. 109 on the review. Find a, oh yeah, that's a good one. Thank you. All of them have. Okay, review 109. We have this piecewise function here. On the top we have negative x plus 1. And that is the formula when x is less than or equal to 3. And the other one is ax minus 8. And you're supposed to use that one when x is bigger than 3. And the question in the book is, find a so that this thing is really continuous. Okay, so this, as you know, piecewise functions can be piece 1, piece 2, and they can whiff, right? This is saying, hey, what would a have to be so they don't whiff, so they're like connect? Well, at which value do they have to connect? It doesn't x have to be 3 up here, otherwise, I mean, isn't that the only meeting point, x, y's of the two things? So let's take our two equations. And we know x is 3, and if they meet, aren't they going to have to be equal? So let's put an equal sign in, and let's plug in a 3 for x. So this is negative 3 plus 1. And then this is a 3a minus 8, right? I'm just plugging in a 3 for x. So this is what? Negative 2 equals 3a minus 8. Add 8 to both sides. Aha! When a is 2, these little sweethearts are going to meet. And therefore, that'll make it continuous. It's always a good thing, isn't it, when sweethearts meet? I think. If they're getting along. So, I guess that took some common sense, didn't it? You had to look at it and say, where do these things have to meet? Well, their only x value in common is 3, so they got to meet at 3. Okay, when x is 3, what's going to make them meet? Oh, when they're equal. And then from there, it's not too hard. By the way, you probably have noticed I really am on schedule, and I have been getting up all the media on time. Usually by the end of the day it's up. And yesterday's I'm calling 1 review 1, and today's I'm calling 1 review 2, meaning why the first one? Because of the chapter. Chapter 1, review 1, chapter 1, review 2. Christina? What about 100? Okay. In this part, determine whether the statement's true or false. If it's false, explain why, or give an example that at least shows that it's false. Okay. So 100. And our problem is the limit as x approaches 3 of f of x equals 1. And then they tell us what the function is, huh? Probably should have left more room. They tell us that f of x is a piecewise, 2 parts, x minus 2, when x is less than or equal to 3. And part 2, negative x squared plus 8x minus 14 And that's only when x is greater than 3. Okay, so is it true that the limit of this function as x approaches 3 is 1? Well, is it true from the left? All we got to do is plug it in right here. What's 3 minus 2? 1. So that one works. How about from the right side? Well, as x approaches 3, this is going to be what? Negative 9 plus 24 minus 14. And what is that? 10 minus 9 or 1? Looks to me like the left and the right hand limits agree, and they both come out to what this thing says, so this definitely appears to be true. So you want to check out your left and your right hand limits. Now if it was false, I would circle where I showed that the two limits didn't come out the same.
Is that negative x squared is a negative by itself? Is that why?
When you don't, yeah. What's the difference between this and this? Or isn't there any? Ah, there is. This one says, square me first and then put the negative on. This one says, do the negative first and then square me. So you got to be careful. That's very tempting. You're probably wondering, why do I have a negative on that 9? Because I had to square it first. Yeah. If there's no parentheses, you got to do the power rules even over the sign. Actually, you know another way to think of it? Isn't this really like negative 1 times? This really is like negative 1 times x squared. And what's the first operation you have to do? I got to square it first, and then powers still come before multiplication, right? Please excuse my dear Aunt Sally. The P on please. No. The E is for exponents. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication division. So exponents come before the 4 operations. Other questions? I think what I'm going to do, I see some people seem to be pretty comfortable, so here's what we'll do. We'll just if you want to go, I'll see you, I'll see you on Monday for the test. If you want to stick around, we'll keep working. Okay, so this is number 73 on the review. Let's see. Find the inverse of the function if it exists. And we're told that f of x is equal to negative x squared plus 1/2. So the first thing you got to do is you got to think of this in terms of x and y. So I just replace the f of x with a y. Then, to do an inverse, you got to swap the x and the y. Now we got to try to solve for the new y. So we would subtract 1/2 from both sides. I would now multiply both sides by -1 to get that negative out of there. And then I would take both square roots. I'm just rewriting this negative x plus 1/2 as 1/2 minus x. Okay, now that's not a function, but it certainly is an inverse. So we have arrived. And that first one is a parabola that looks like this. It was in the book. This one is going to be tipped sideways. In fact, maybe we should show that. Let's just quick put those up here. So the original, let's get rid of that. The original was -1 times x squared plus 1/2. And then, what's this one? You got it. It's two of them. Square root. I forgot. What do I have to do for square root? Let's just do it to the 1/2 power. Can you tell me what that was? It was 1/2 minus x? Or, yeah. 1/2 minus x. And then that's to the 1/2 power, right? Because it's a square root. Okay. And then the other part is the negative root. -1 times 1/2 minus x to the 1/2 power. Yeah, and do you see how one is, if I put, here, let's put one more function in here. Good old identity function. And you see how the one is just a mirror image of the other with respect to that line. So that's kind of a cool check. If you don't get that mirror imaging, then you didn't find the inverse right. So, I don't know, you might do that. Uh-huh. Just making another blank page here. I ran out. Okay, you said 68. So this is the review. Number 68. And, okay. Use a graphing utility to graph the function and find the domain and range. I doubt if I'd have you do that on a graphing utility, but let's put it up here and talk about, I mean, I can do it if you want, but let's talk about the domain and the range, because that would be the part that I would expect you. -7/8. So let's think about domain and range here. Is there anything that x can't be? See, oh, I see. You mean if that part comes out to 7/8, then that would cause this to be 0, but that's okay. Can't the function be equal to 0? See, the only ones you got to watch out for is there division by 0? No, not in this case. Is there a place where a square root might turn out to have a negative? No. So basically what that says is you use whatever you want. So domain would be negative infinity, positive infinity. And basically, isn't this mx plus b? Isn't this a straight line? I know it's not a horizontal line because this would have to be 0. I know it's not a vertical line because then you don't even get a y. And so, if it's not horizontal and not vertical, and since lines go on forever, you're going to get every y value too. And so, both the domain and the range on this one is negative infinity, comma infinity. Yeah. I better complete this by putting that down. Want to look at any others? Since this is a negative slope line too, it's got to be heading downhill. So. Okay, 54D. I need to make a page again here. Okay, number 54. Part D. Well, let's see what's going on 54. Find the general form of the equation of the line passing through the point satisfying the given condition. Okay, the point is 1, -3. And in part D, the condition is that it's perpendicular to the 5x minus 2y equals 3 line. So what I got to do is take that equation for that perpendicular part, and I need to think of it, I need to get it solved for y first. So -2y equals -5x plus 3. Divide both sides by -2. So now, there's the slope of the original line. If that's that slope, then what's mine? Because mine is perpendicular. Right, so my slope is going to be -2/5. So now we know this. That our line must be in this form. Now all I got to do is find B, and I got it, and that's where this comes in, the point. So now we plug in a -3 for y. We plug in a 1 for x. Solve for B. Add 2/5 to both sides. I suppose let's do it in terms of fifths. -3 is -15/5. And if you add 2 to that, it's -13/5. So, the equation must be y equals -2/5 x plus -13/5.